Alright, so here is this week's assembly. What we're going to do, these parts here. I'm going to call this a roller, okay? And it's pretty small actually. We'll get to that in a minute. What's going on is the base of it right here is brass. These wheels that are going to, on this shaft that lays in the base are brass as well. And then we got a steel shaft that lays in here. You'll see that in just a second. And here we go. Here's the roller, and you can see that it's just a 1/4 inch. Here's the material for that, and we're going to do that right now. Here is the base of this, and this will get done on the mill, and that'll be next. And then we've got the shaft. So it's stainless steel shaft. And first thing we're going to have to do, since we're doing this first, is we're going to have to grind a tool. And I found this. It looked like it was at some point a grooving tool. I did not make this. I found it in the shop. And so we're going to go over to the grinder, and I'm going to grind this tool into, I'm going to put this here into this radius, so we can see that the radius of this is a 32nd. So the diameter would be a 1/16 of an inch, which is tiny. The width of this is of the whole part is 1/8. That we'll do on the lathe. And this right now we're gonna grind this to this profile. So it's gonna, right? See that? I think right. We're gonna grind that to that profile. Here we go. What I've got here are some, you saw another set before, but these are some radiusing gauges. And we're after a 32nd radius, so we can see here it says a 32nd. And we will, there it is. We're going to use this to check our profile. These are really cool. This is square. They have a inside cut out right there for the radius, and then there's one there so you could put it in and measure. They're so useful for all kinds of applications. So let's go to the grinder. I'm going to measure the width with my calipers, and currently I'm at 75 thousandths. So I don't need to take off that much. Remember, we want this to be a 32nd. And that's partially why I grabbed this. I didn't want to consume a lot of time of me cutting the tool. So here we are at the grinder. And still haven't found the best place to put this. Hope that doesn't vibrate off. So these you got to be real careful with. These are expensive. We want to keep that in good shape. I got my water. I know this is a really tiny, so I want you to pay attention to how light I'm touching the grinder. I'm not going right in there, okay? I'm really light, and I'm looking. It's hard for me to say how I'm seeing this, but what I'm doing is I'm kind of keeping everything parallel. Fix the light. Maybe you'll be able to see if I fix the the light better. Just take care of that corner there. Okay. All right, let's see where we're at right now. I'm not worried about the tip part yet. I'm gonna do that last. So let's see where we're, okay. We're holding shape, which is good. Okay, let's put some water in there. So now I'm starting to remove just a slight amount of material. Let's see, how are we looking here? We look pretty good. It's not the straightest tool I've ever made, but that's okay. I'll show you how to. I'll show you how to get that go. How to. Let's see. So you can see in there where it's shiny, and then a spot where I didn't. It's dull. So we're gonna have to be real gentle here. Okay. And so I'm checking in a few areas, make sure that I'm parallel. So let's see, it's 67, 68, maybe down at the bottom there, up at the tip, 66. So I'm not totally parallel, but I might be able to. So gentle. Okay, we're there. 63. That's where we want to be. 63. 64. All right, so that's it. Looks pretty good, actually. And now real gentle. I can't tell you how gentle I'm being. I'm just gonna start rounding over this tip. All right, that actually looks pretty good. Now I'm gonna use the radius gauge, and I'm a little flat. I'm a little flat on top. I don't know if you can see that. I hope so. A little flat. Actually, I'm so close. I'm gonna put the rest in with the stone. I'm just going to remove a little bit down there. It's called a chip break, and just a slight. Yeah, okay. So I think that looks pretty good. You can see okay. And turn the grinder off. That's really close. All right, so I'm gonna put the rest in with a stone. Here's my stone. One side's coarse, one side's fine. I'm gonna use the fine side. What I'm gonna do is I'm just gonna put a little bit of oil on here. Okay. And I am going to start honing this, is what it's called. I think I am. I have another stone I could do this with, but I do like to use these. I'm not using the I don't use this part of the stone for this kind of operation because I like to keep this as flat as possible. And I dress these up, make them flat with sandpaper and a granite table. But we're not gonna get into that for this class. It gets all the chips out too. Just real gentle here. I'm honing in this radius, and at the same time, it's like sharpening my tool. Wow. So we're really close there. Well, all right. Not as close as I thought. All right. Okay. Let's see. Oh yeah. We're there. I think you probably can't see it, but it's looking pretty good. And you can see where it's, and I can feel it's nice and sharp. Good. I'm doing what's called honing. And I have off of the gauge, I have a visual in my mind about the high spots that I need to remove. So I'm gonna check now, see what we... Yeah. All right, so we're getting close. We're getting close. So I'm gonna use a finer stone at this point here. And a really fine stone. Dress this up. I can feel it with my fingers that it's nice. And there we have it. I mean, it's so, there's just a little tiny bit. We're good. We got it. We got it. We got it. So let's go over to lathe. All right, so here we are. I got my, I got the 5C collet to hold with a quarter inch 5C collet. Slide this in here. Tighten this up. I'm going to use the finishing tool that I used last time, and I'm just going to really lightly face this. Then we're going to put an 1/8 inch hole in it, and let's see, maybe I can get this so we can do 2 or 3 without having to take out the material. So the rest of the tools for the job is my handy 3-corner file. I've got a number 2 center drill, so it's quite a bit smaller than the number 3, that 1/4 inch one, and then I have the 1/8 inch drill bit that will be drilling the hole in the center. I'm not going to be drilling that far. I'm only going to be drilling maybe about 1/2 of an inch or 5/8 of an inch deep. And then the last tool we're going to be using, instead of using a parting tool, which you've seen, I have a, there we go, tool that I rigged up. Oh, here it is. And it's to cut a groove, but I'm going to use it as a parting tool because there's going to be a hole in the middle, and I'm only going to have to go 1/16 of an inch deep, okay, to part the piece off. All right. So that's the plan of attack. So, and let's see how it goes. I'm just going to go ahead and face this off. I'm running about 650 RPM. I probably could be I'm going to go up to, with carbide, and I'm going to go up to 930. I'm going to lightly touch off there, and I'm only going to remove a few thousandths of an inch. Okay, that's it right there. Now I'm going to drop the lathe back down to 650. I'm going to remove my tool. And in the drill truck here, I'm going to put that center drill in. Okay, and get the tool post out of the way. Bring this up here. Pretty good. All right. And I don't want there to necessarily be a heavy countersink in here, so I'm going real slow. There we go. I think that looks pretty good. Let's see how we did here. I'll get that out of the way and I'll check with the drill bit. Well, maybe we will come back. There's no countersink right now, and just put this back. So you guys, these are small parts. It's a different style with small parts. Just a different thing. Really slow. And I'm pecking at it. Alright, that's it. That's all I want to do. Bring the tailstock out of the way, and I'm going to take the drill bit out. I take the drill bit out, even though I'm going to need it again. Okay, the number one reason I leave it out is actually for safety, because when I come around here, it's really small, I can't see it, and I'm going to bang my arm into it, and I'm going to cut myself. And then the second thing is that I'm going to break the drill bit, so I'm going to take it out. Okay. And let's see. Now what we're going to do is put the tool we just made in. We're going to have to adjust its height. And first I'm just going to eyeball it straight. All right. I will tune it out in just a moment. So I'm going to see, remember, it's like parting, so I'm going to want to be a little bit positive. All right, so I'm going to raise the tool up. And it's going to be a little, I'm too positive. We'll start there. That looks pretty good. That looks pretty good. Yeah, maybe just there. There. Okay. And I'm gonna looking at light and I'm looking at the gap between the face and the part. And that looks pretty good. Okay, so I'm gonna rest this up against the part very gently. That looks pretty good. Okay, and I'm going to zero out my depth gauge. So preload a little bit. Just preload it a little bit. Zero it out. Okay, so now I have my zero. I'm gonna back the tool off over here, and I'm gonna go in, the width of it is a 1/16 of an inch, right? So there's a 1/16 of an inch. So now the face of it, the face of the part and the tool, if you can see that, they're in line here, okay? So now what I can do is I'm going to move it over. I'm going to zero this out again, sorry, and I'm going to move it over a 32nd. So that's 31 thousandths. All right, so there's that. And I'm going to do a touch off. All right, so I just touched, all right? And I need to do, I need to go in a 1/16 of an inch as well. So what I'm gonna do is I'm just gonna say, okay, there's 28 thousandths, okay? So really slow, I'm going in here. Real slow. Real slow. So there's 28, all right? I'll do another 25. Hold on a minute. I might be, I'm sorry, it's a 32nd deep. So I'll put, let's see here. It started at 28. I think. Yeah. So that's where we started. So there's 28. There's 30. So I went over. I went over by a few, just a couple thou. That's all right. It'll still work. I still will make more. But I went over. The next one I will not. Okay, now we are going to take this grooving tool. Okay. And we're going to do the same thing. So you can see that needs to come up quite a ways. So grab our wrench and bring this up. There, just a little tiny bit positive. And what I'm looking at now is I'm looking at this face. I don't necessarily care so much. I just want this face right here to be good. And the tool looks like this, all right? So as it goes in, right, it's gonna, and there's relief in the back. So what I'm gonna do, I need to measure the width of it. What I'm gonna do, the width of this tool is a 1/16, just like the other one. Is I'm gonna very lightly rest this along that face there. Okay. I'm gonna zero out my indicator again. There's the 0. There's my 1/16 of an inch. All right, and the width of the part is 1/8, so 125. Okay, and now real slow. Real slow. There it is. Okay. So there's the first one. Now this time I won't go over. And so now I'm going to grab the finishing tool. All right. There's 2. 4 more to go. Let's see how we're doing. Let's see if we're over or under. So we're 5/1000ths under, which is actually what we want. I was going to sand that in. That one is 2/1000ths under. Okay. With the dial calipers, if we measure it with micrometers, it would probably be a little bit different. That one might be over. No, there it is. Okay. So we're within a couple thousandths, and what I'm going to do is I'll sand these, okay, and make them look nice. I think this is a nice thing about Collets, is that when you take things in and out, I mean, it doesn't line up back perfect, but it lines up a lot better than it does in a chuck. This is just some Scotch-Brite. I want to make sure that I've got enough in my hole to at least do one more. I do. All right. Okay, real quick. We're not going to spend a lot of time. I just want to talk about some fasteners, okay? Real quick. 5 minutes. First, I want to talk about just your regular old bolt. Right, so we have your bolt, okay? And when you go to the hardware store or Home Depot, you often might notice that there's some markings on this bolt head, okay? And I want to talk about those really quick. Let's start with just the three markings. You might see this, and this is very common, okay? The strength of the bolt is known as its grade. So for example, this marking is a grade 5. All right? And what that's referring to is the strength of the bolt, but the alloy of the metal that's being used to manufacture the bolt, all right? So this is actually really important. So 3 lines on it, which you'll see often at Home Depot, is a grade 5 bolt. That's a fine bolt, okay? No markings on it could mean 2 things, all right? That there is no grade at all, and it could just be pot metal. What I mean by pot metal is just like they throw metal in a pot and they make a bolt out of it. And that's awful. Like, that's bad news, okay? Or, technically, it could be a grade 2 bolt, okay? And I'll give you the strengths in just a moment. What you need to use on your car, to hold your car, not like to hold a piece of interior panel on, but to, like for your suspension components and assemblies like that, is what's called a grade 8 bolt, all right? A grade 8 bolt has a pattern that looks like this on the top of it, okay? And there are thousands of fasteners and probably hundreds of grades of different bolts. The metric system has its own system to define strengths and tensile strengths of bolts, okay? And I just want to go over those three because they're what you're going to find on your car. They're what you're going to find at the hardware store, primarily, all right? So, a grade 2 bolt is 60,000 psi. A grade 5 is 120 psi, 120,000 psi, and a grade 8 is 150,000 psi. Okay, so that's really important. I want you to know that. What a lot of people don't know, and is that we're going to talk about these now. This is a socket head cap screw. The black oxide ones, like the one I'm holding, they're actually even stronger than a grade 8. They're around 170,000 psi, okay? And they're unmarked. They don't say that on there. Now, you'll find cap screws made out of other material. They do not have that tensile strength, okay? Just these black oxide ones. Okay. All this information, by the way, is available at McMaster Car. You can find it there. It's very easy to look at and figure out what's going on if you're so interested. Okay, so let's talk about probably the 3 most common types of fasteners other than a regular bolt, okay? And we went over screws a long time ago. But in the machine shop, we deal with, I have some bolts here, we deal with what's called mostly a machine screw. And a machine screw has threads like this. We know all about threads now, but what it's actually called is a machine screw. There are different profiles, heads, and there are many, hundreds, maybe thousands, okay? But probably the 3 most common are these right here, okay? This is what's called a socket head cap screw. This is what's called a button head cap screw. And this is a flathead, okay? And these profiles are actually really important. And we need to know how to finish the hole, okay? So remember when I was showing you this, and I guess I wasn't very clear on it, this is a countersink, okay? And if we notice with this flathead machine screw, these profiles match exactly. Excuse me. And I'm going to show you that on the board. Like I said, this is just going to be real quick. Okay. So here's what we're going to do is countersink our hole with this countersink. Now, I prefer the single flute ones. There are multiple ones available at Home Depot. Most of them are junk, by the way. But what this does is it enables our flathead screw to come in here like this. Okay? I think that's pretty straightforward. This is called countersinking. I'll write that up there. This is called a countersink. Let's move on to the next one. Now, button head, which is this round profile here, it doesn't have a countersink. It does. Here's your material with your hole in it, and the button head just sits right on top here, like that. Okay. What would be? Why would you choose this over, say, the regular socket head cap screw? Well, if for say you needed to, it was close to an operator, or it's like in the interior of your car or something like that, somewhere where you might brush up against it, like your arm or your hands, they have a nice round profile to them, so your clothing won't get caught on it. I mean, there's you get what I'm saying, right? Okay, we can come up with thousands of ideas about why we would do that, but that's why they have those. And then the flathead's pretty obvious. So if you didn't want anything to come in contact with that, you want it to be nice and right, that would be a application for that. Now, there is something called, and people get these confused. This is called counter boring. Okay, so it's different than a countersink. A countersink has the angle in it. Okay, now a counter bore, the socket head cap screw fits inside the bore, so it's going to look like that. Okay, and there's many ways to do a counter bore, but this is actually a counter boring tool. Okay, and it's 3 flutes. And it has what's on here, what's called the pilot, and we've talked about pilots, so we know about pilot. And what the pilot does is, as we drill a hole, right? So the counter bore isn't there yet, and this pilot doesn't have any cutters on it, and so the pilot runs down the hole that we drilled for our screw, and then we get a nice flat bottom. Okay, you want to run these slow, in the neighborhood of 100 RPM. Okay, that's what I do at least. Someone you might say, "Oh no, you don't do that," but that's what I do. I have the best results with that. I don't like to run them fast; they chatter. Okay, that's counter boring. Okay, so it's called counter boring, which is what we're going to do today. In a moment. The only other thing I want to add real quick, I think I got everything that I wanted to talk about, is the angle of the countersink and the head. I'll give you there's lots of different angles. There's like 4 or 5, but the 2 most popular is 60 degrees and 82 degrees. And actually I find that 82 degrees is the most popular one. That's what this is. This is an 82 degree countersink and an 82 degree flathead machine screw. Okay? All right. So here we are, and we made the rollers already. Remember those? And there's 6 rollers. We're gonna make the shaft last, but we got to make this base to hold our assembly together. So here it is. We're going to do it on the mill, and we're going to use the scrap material from the bridge that we made, the mystery bridge, and we're going to prep that. We're going to square it up, and then we're going to go to town on it, and I'm going to be very detailed about how to find corners this time, because there was some confusion about that. Okay, here, other than the fly cutter and the end mill, which, you know, these are the tools we're going to be using. I've got 2 very small 1/8" end mills here, and so as you can see over here, we're going to run this ball end mill through the center. Okay, right along here, so straight. Okay, And then we're going to take this 1/8 inch end mill and make these slots or grooves. Okay, that's what we're going to do there. Now we've got a drill. So if we come down here, we can see the hidden lines. We're going to drill through here, and we're going to take this really tiny counter bore. It's not a countersink, it's a counter bore. And we're going to make this counter bore to fit this number 2 brass screw. Okay? That's what's going on. That's what we're going to do. Okay? So that's the part right now. And what I'm going to do is on this material here, we can see that we've got 2.5 inches long. We've got down here, it's 300 thousandths wide and 475 thousandths tall. This is, as if we remember, is around a little over 500 thick this way, right? Remember, it's like 555 or something. Yeah, 556, okay? Maybe there was a burr there. 556, 555. So what I'm gonna do, I think, is this is 860 some, all right? So if I split this right down the center and then on the bandsaw and then cut it off at 2.5 inches, of course heavy, right? I'm gonna end up actually with 2 of these. Now we're only gonna make 1, but I'm gonna be doing a similar project, just different, next semester. So I'll use that, I think, for next semester. So I'm gonna mark this out, and I'm gonna show you another technique. I'm gonna show you one that I don't want you to do, and one that you can do. That's good. So usually we leave the line. Remember, we leave the line. I want to actually just split this right in half. So what I'm going to do is I'm going to mark right in half, and then I'm going to cut right on the line. That way I have. So I'm going to grab the measurement here. So that's 8.6. I'm sorry, 860 thousandths. All right. So half of that is 430 thousandths. So here's 430 thousandths. 430 thousandths. Okay. This is not a good technique. I'm going to show it to you anyway. And what I'm going to do is I'm going to use the side of my caliper and write it along. Okay. And I'm going to scribe a line. These calipers are stainless steel, and this is bronze, actually, I think, for sure at this point, because of the way that it oxidized over just a few days. I'm going to scribe a line in here. I want you to know that this is not good practice, okay? So I'm just going to rest my calipers here, turn it up, and I'm going to scribe a line. Okay, there's my, you can barely see it, but in the right light you can see it, and that's right down the center of that part. Now I just need to take a ruler here and measure off 2.5 inches, and I'll show you the right way to do this. Okay, so what I'm going to do is I'm going to use a scribe. Okay, this is a scribe, and this is the way you should be doing it. All right, so that was the right way to do it. Now there is something that machinists use called Dykem, and what Dykem is, D-Y-K-E-M, I think, or U-M. It's a blue dye that you can, so it enables you to see all these scribe lines really easy. I'm not going to use that right now. Maybe later I will, but I'm not going to use that right now. I'm going to go this route. So I'm going to go over to the bandsaw. I'm going to cut this right down the center, and then I'm going to cut this off but leave the line. All right? All right, here we go. So here we are at the bandsaw. Safety glasses on, and look at that. What needs to happen here? Okay. This, right? This needs to come way down. So let's adjust that. Doubt you can see that, but I'm about 1/4 inch off the top of my material, okay? And this blade's a little bit aggressive, but I'm in high speed because it's soft material, and I'm going to go, I'm just gonna go slow, okay? And it might warm up on me. I might have to cool it off, but let's see how it goes. So I can barely see the lines. I know you probably can't. Wait for the machine to stop. Wait for it to stop. Okay, so there we go. That's a little warm, so I'll just put that. So here's my bench. I got the tools all set, my collets, you know, nothing, there's nothing unusual here. This is as standard as we go. I'm gonna be using, I think, this end mill. I think that'll work nicely to get the sides, okay? I could use an end mill to clean this up, like from our bandsaw cuts, and make it all true and nice and everything. But I don't think I'm gonna do that because I'm gonna be polishing these parts, and the fly cutter gives me a really nice surface to sand and to polish. So I'm gonna use the same fly cutter, right? Nothing new. And what I am gonna explain more thoroughly is finding this corner, because from your responses, I have noticed that maybe I didn't. It's not you guys. It's my fault, and I haven't explained that well enough. So I am going to spend a little bit of time doing that, and I am also going to, you know, I'll make this part. A lot of it I'll put in high speed so the video isn't eons long like before. But I really want you to see how this is done. All right. And you know, and for those who are into this, I'm giving you all the goods here. I know you're like, shut up, man. We know. So we have to go through this. That's pretty good. Of course I have my print here. So we can see that I am 2.6, so 2 inches 600 thousandths roughly. And then oh no, we're good. I'm at 0.4. I got it backwards. I'm at 0.4, so I need to be 0.3, and I'm 100 thou heavy, so that's good. And then of course, right, we know that we're about 75 thousandths large on the height. My two sides that are parallel are here, okay? So what I'm gonna do is I'm gonna take this square and I'm gonna see how that looks pretty good. And that looks pretty good. All right, so I'm gonna put this in the parallels like this and barely touch this with the fly cutter just to remove the saw marks, all right? At least that's the plan. And I think it'll work. Actually, I know it'll work. And so, got the vise here all set up, and you know, we're cleaned out, a rag. A lot of pros use compressed air, and so do I. I gotta be honest with you, most people do. It's not the right thing to do. You need to use a rag or a brush. But I also want to say something about that. what, after you blow it out, which you're not supposed to do, especially here at the school, but after you blow it out, there's oil in there. And even if it's not like a puddle of oil, there's still oil. You need to wipe it out with a rag. And I see machinists often, especially on YouTube, that are really good. They just blow it out, and all it takes is one chip. And you guys know that now. But all it does is take one chip, okay? And your part is ruined. Yeah, it goes that way. Okay, so let's see what we're doing here. Let's see how this. All right, so okay. This really isn't the right way to do this, but it's the way that I'm going to do it. I'll be honest with you, this is not the right way to do this. But I am going to do it this way because I kind of know what I'm doing. And see it lift up right there? Yeah, it's because the bottom isn't flat. And what I want to do is I just want to see if there's, right? And so I thought ahead, and I know that, take that out, not doing anything anyway. And I gave myself extra just because of this, okay? So what I'm gonna do is I'm gonna put the fly cutter in, and I'm just gonna take like 10 thousandths, or it might end up to be 20 thousandths off of this to make this perpendicular to the other two sides, okay? And we'll check it with a square to make sure that it is. Let's see, let's get my collet. I got some chips in my, I can see there's a piece of a little brass chip in there. That is, we don't want that. That's bad. So I've got to really clean out my collet. Make sure that there's no collet holder. Make sure there's no chips in there. That is not good. Yeah, let's do this. I was gonna put on my tripod, but I think I'm gonna do it. I'll do it this way. Moving the X angle. You guys get to see more this way, I think. But you know, I'm not filming. This is not my forte. Okay. So I'm real close up there, right? I'm real close. So let's take it out, and we're gonna deburr it. That looks pretty good. Actually, it looks great. We're gonna deburr it. And what I'm going to do is I'm going to use my square, and I'm going to make sure that what I just did is square. I'm going to hold the base, remember the engineering square or the machinist square, and I'm gonna slide it down in the light, and I'm gonna look for gaps in there, and I'm gonna do that on both sides, okay? I'm up here on the light, and no light whatsoever. Turn it around. Oh, nope. We're looking real good there. Okay. We're looking really good. Okay, so what I just did, I got lucky. Like I said, that was not really the right way to do this, but we pulled it off. Okay. Small parts, as with big parts, small parts are just different. Big parts are different too. It's just, you just gotta go with it, right? So I'm gonna put this in here. One parallel. Make sure that, yeah, I'm good. There's no chips in there. I'm gonna push down with my thumb, snug up the vise. I'm gonna grab my dead blow hammer, and look how light. No whacking. That's not the point. The point is just to seat everything. Okay, we're just trying to seat everything. That's it. Okay. If you need to whack it to get it in, you're doing something wrong. All right. So that's good to go, and I got this edge hanging out, so I can take a measurement. All right, and I'm gonna lower the table so I don't crash, and we'll go ahead and do this. So touch off again. All right. So I'm raising the table real slow. Must have been farther away than I thought. There we go. Okay, so I just touched. I'm gonna back it off, and I'm gonna raise it about 10 thousandths. So right there, I'm gonna raise it about 10, and then I'm gonna put it on 0. So after this cut, I will have the machine zeroed out to my part. All right. So I don't think I need to tell you at this point anymore, but I'm turning the machine off, okay, before I take a measurement. I don't think I need to say that anymore. And we're at 365, I'm sorry, yes, 365 thousandths, okay? So the dial caliper said 365 thousandths right there. We need to do 300, so we've got 65 to go. I think I'm gonna do, I don't know yet. How about if I do 25? I'm gonna do 25,000, I'm gonna raise the table, 25 thousandths. The chips are gonna come towards me, so I'm gonna get out of the way. I'm gonna do 25 again. That'll take me to 50. Okay, so we're gonna go to 65. And this is our finish pass. Okay, so before I take it out or move anything, I want to measure. Make sure it says 300. So that says 300, maybe, it might be 1,000. I'm not pretty much spot on. So we will go ahead and remove I'm gonna lower the table. Oh, no, I'm not. I'm gonna leave the part in, but I'm gonna lower the table and I'm gonna change tools at this point. I'm just going to be removing a very, very small amount. There. Alright. Real slow. Real slow. Okay. I'm gonna lower the table. And now I'm gonna take the part out. That's right. So now, file. Oh yeah, okay. So I've done 5 of the 6 sides. What I'm gonna do now is I'm at the width, which is 300 thousandths on the money, well, to the Daly calipers, and then I've got a bit to do, got a bit more to do on the top. And I'm just gonna do that with the end mill. And I'll explain why in a minute. There, that's good. There we go. So I got that. What's left is the height and the length, okay? Let's see where we're at on that length. Yeah, we're good. Okay. Let's see. I still look pretty good in there. I'm gonna bring this, make sure I got the right, yeah. I'm gonna do this. Yeah. All right. Okay. Snug up the vise just a little. So, oh yeah, we're good. And when it goes in so well right off the, right out of the gate, like, you've got a trued up, you got a squared up part. I mean, it just, All right. So what I'm gonna do is I'm gonna do the height with the end mill, and the reason I chose the end mill is because it's in the machine. I'm gonna end up removing most of the material up here, and I don't need that nice finish that the fly cutter leaves. Okay, and then we'll knock the side off to 2.5, and we can get going on the actual part, which will be great. And it looks like I'm not even gonna have to take it out. So let's we'll take some measure. I don't even think I'm gonna need to take it out, and that'll be great. All right, here we go. I'm just gonna touch off. Here, come off the part. I'm gonna center the end mill a little better, right about there. And I'm just gonna raise it, I don't know, 15 thousandths because I don't want to go over. I want to stay in control. That's the name of the game. I want to stay in control. Okay, turn off the machine. I've got 42 thousandths to go to 0.5, and I need to be at 0.475. So I'm gonna go ahead and I'm gonna take 42 thousandths. I zeroed it out. I'm gonna take 42. And that's gonna put me right at 0.5. All right. So if I measured correctly, that should put me right. I'm checking for burrs, by the way. A little bit more. That should put me right at 0.5. That's the problem with doing it this way, is you gotta get the vise out. Yeah, so I'm a little, maybe 501, and I need to do 475 plus some sanding. Let's do 25 and we'll call it. All right, so I'm just gonna put this at 0. I could have done the math. Yeah, and then I'll go to 25, actually 26, and then bring this over. Turn the machine on. I'm gonna slow it down a little. This is my finish pass. Bring the tool around. Gonna touch off here. All right. Okay, now I'm going to take a measurement. So I'll bring the part closer to me here. Get rid of some of these chips. And see what we got. I'm gonna bring the part a little bit closer to me. Get under here. This measurement actually is really important to me. So I'm at it looks like 255, 555. So I need to go 55 thousandths. I'm gonna zero out my X. Okay. Go ahead and turn the machine on. And I want to do, I'm just gonna do 20. So there's 10, there's 20. Now I'm gonna do another 20. There's 10, there's 20. And then I'll finish off with a 15. 10, 15. Hope you can see that. Here's my finish pass.
Okay. It's tricky to get in there. I'm on the money. 2.5 on the money. All right. So let's lower the table. And change tools. So remember, I have my zeros, so I'm gonna go over to 188. All right, and okay, turn this on. I got a it changed the cutter here. Oh, forgot to turn on the mill. And I'm going to touch off the top, and then in increments like we already talked about, I'm going to 20,000 depth of cut, and I'm just going to go back and forth. Okay, so here we go. I got the speed up because I have a really small cutter in there. All right. All right, touched off. And 0. And 20. I'm going to adjust my power feed rate. I'm going to cut air. I like that. Actually might be a little slow. That's too slow. Okay, that's good. Okay, so stop the power feed. 40 on the dial. $60. You get it. So I want to go to 75 because remember my dial's at 80. Okay, so I'm done, and I've already got my 0, right? So I'll lower the table. There's 0. And now the next one, 1038. I'm sorry, 613. Before I move anything, I'm just going to take a quick, very inaccurate measurement. And I just want to make sure that, because if they're not deep enough, I can go back and make them deep enough. I'm using the depth gauge as part of the we're on 200. So we're done with the milling operation of this part. So go ahead and take it out. I'm gonna turn off the mill so it's not so loud. Let's see what we got. I like it. Okay, so you can, remember I told you I didn't really go through, I could just feel it, right? So we'll just take the drill and the drill press, and we'll pop that in there. That That should be okay. And you know, deburr it, of course, and round over those edges. Maybe I'll do that on camera again. So let's go finish. Close. This is the shaft that's going to hold those rollers in this base. So this shaft is going to go in after I deburr it. It's only an 1/8 inch. So instead of using a hacksaw or a bandsaw, I set up a die grinder actually. Well, actually it's not a die grinder. It's a cutoff wheel. So what I'm going to do is mark off 2.5 inches. That's what we need to do. Get my Sharpie to work. There we go. And you guys, safety glasses for this operation are absolutely 100%, and they always are, but specifically in this. This is a die grinder. It's an air tool with a cutoff wheel in it, and it's a lot more gentle than the hacksaw or a bandsaw, and it'll be quick. So all I need to do, I want you to be able to see it here. I think, make sure you can see it. It's just like I'm gonna leave part of the line, like a 30-second, and I'm gonna hold this end out here with my fingers. See why safety glasses are required? Where are those sparks coming? Right by my face. So actually it's too close for me. I'm going to move. And I'm trying to get in a position so you can see here. This'll, there we go. That's it, all right? That's it. So I'm gonna undo the air tool right away. I'm not even going to set it down. That's real important, safety-wise. Before I even undid it, before I even laid it down, I undid the airline. I have a hook actually over on the side here specifically for it. That way it doesn't go off, because you see, it's not plugged in, right? Okay. But if I lay this down and the on handle goes off, boom, right? This thing's gonna go flying. Okay. So that's super important if you ever use one of those. I mean, super important. All right. Now where's there it is. I'm just gonna check this against my scale, and I'm about an 1/8. About an 1/8 over. And what I want to do is I want to do as much as I can. I think I want to get this really close on the disc sander, and then I'm going to put it in the lathe to just clean it up. Okay. So instead of like up close, I'm going to do this one farther away for you. I changed my mind. I'm going to do it on the grinder. Just so you can see me work. So I'm letting it spool up. Look how gentle I am, using the whole face of the wheel. Okay, I can't tell you how important it is. And what I'm going to do is I'm just going to get a rough idea about what I got left here. So it's looking like 2.6, okay? 2.6. This won't take long. Deburr. Take another measurement. And I'm getting an idea about what I just did and how much that's taking off. So that took off quite a bit. I'm down to 235, so we're gonna have to go a little easier, huh? So it's 219. I got 19 thousandths left. Whoop. Got 6 thousandths left. And that's probably it right there. Ooh, hot. Okay. Let's see where we're at. Right there. So right there. So what yeah, that looks pretty good. So I'm about 5 thousandths under, I think. I'm gonna round the ends off, right, like in the drawing. I'm gonna finish that in the lathe, but I'm gonna get ahead here and do a little bit on it on the grinder. Just a little. Getting there. I'm gonna finish it with a file and sandpaper. Just wanna do like the roughing part. All right, that's pretty good. Off to the lathe. So I got an 1/8 inch collet in here, and then I have my rod. I'm gonna put this in here. Got about 5/8 of an inch sticking out. And, you know, my famous file. Of course, I have my glasses on and everything, okay? And then .400 sandpaper. Okay. And some fine, it's the black Scotch-Brite. See how this polishes up. Okay. So that's looking pretty good. What I'm going to do is I'm going to extend this out a little bit more than halfway and really gently so I don't bend it. I'm just going to clean it up a little bit. Okay. And you can see there's a little bit of run out. Looks pretty good. Right. Looks pretty good. Do the other side. So I got it sticking out about, I don't know, 1/2 inch, 5/8, 1/2 inch maybe. Okay. We'll pull this out a little bit, like we did before, real gently. All right. That looks good. So I've got my 3 favorite files. I got a regular flat file. Let's see here. It's definitely, it's fine. There's nothing on the tang. And then I've got a another file, another one of my favorite files. It says Final Cut, and you know, one side I've ground smooth, and then of course, you know, my triangle file that I use pretty much on every project. And I'm just gonna put that in there, the triangle side, right? And that is going to ease off those corners. So I got it in there, like, right? With that corner that I ground off, so I don't have to worry about it cutting anything. And there. How does that look? That looks pretty good. Okay. So I got that taken care of. Now we got to round this off. So I'm going to use this roughing this file, the coarsest one out of the 3 for this, and you know, I'm going to hit the disc sander. I don't know. You guys have seen me do this before. You're probably like, it's nuts. But I'm gonna do it. So I can't stress enough, if you're not comfortable doing this, I really don't want you doing this. This was it'll sand off your knuckles, you know? I don't know. But I've been doing this a long time, so. Done. Yeah. Yeah, I know. I know. But that's what they pay me for. All right. So I got my medium file. And all I'm really doing is removing file marks and any kind of irregular shape. Oh. That's why I grind those edges smooth right there. And also I don't file my vise around this side. Grind the edges smooth. Okay, that looks pretty good. No, let me get a little bit more in there. This side, down that end needs a little bit of work. So I moved my thumb and applied more pressure where it needed more work. Okay. And I think that's pretty good. So, take this out. Oh. Wrong. I always do that. Wrong vise, because I got the vise in the vise. Ah, Blake. All right. This vise. Okay, let's go over to the. What you're seeing here is a. Well, I guess you could call it a micro flat. It's a granite surface. It's ground very flat. And what I've got here is some sandpaper that I'm going to get wet. So I wetted my sandpaper, and believe it or not, the water underneath the sandpaper creates like this kind of vacuum. Not so much when it's been folded like this, but what I'm going to do is I'm going to really lightly, I'm rolling it along those radiuses that I just sanded and filed in. And you can really see it start to come alive. The parts really start to come alive when you do this. I really love the machined look, but I am going to be buffing it, so I'm gonna sand it. I really do like that look, that machined look. A lot of people don't. I think you got to be if you're a machinist, you really like that look, and I think some people don't. They just don't appreciate that look. I really love that look, but I've decided on this project that we're buffing, and I'm not going to change my mind. So I'm just rolling this along that edge, along this flat surface, and looking to see if make sure I'm removing all the file marks with the sandpaper. And I'm looking really good here. That's what I'm up to. All right. And now what I'm going to do is I'm just going to lay this flat like this, and I'm going to use like a figure 8 pattern, and that will really, you'll see. And this is why we use the fly cutter. The fly cutter leaves such a nice finish that I don't have to do this for very long before we buff. And then this is 320 grit. Actually, it's worn out 320 grit, so it's more like, I don't know, 350 or 400 grit. But I will move along to 400 grit, and I'll do the same thing. And then I will move along to the next grit, which in this case, I think I'll just probably bump up to 800. And so now the scratches, not what's inside that light that you see, but there are some scratches in there from the fly cutter. What that is that when that fly cutter comes around, or it's coming around at 1,000 RPM, okay? What happens sometimes, and the geometry of the cutter made it very clear what was happening. A chip gets, just a very small amount of a chip either gets caught under the cutter or is welded on to the cutter. It looks like in this case it was doing some sort of, because it's very consistent, but that's what that is. When people talk about finishing and the quality of the finish, those are some pretty serious considerations. So feeds and speeds, the geometry of the cutter is very important. That's advanced machining. I'm not going to get into it, and I'm definitely not an expert in it. But that's what's going on there, and that's why we're seeing that. And it's really making quick work. So let me get the right light again. I think you can, yeah, see how it's coming down, and it's coming down. Another thing I could have done is I could have glued some sandpaper onto like a piece of wood. So I'm just going, I want you to see this, how it's coming down and the scratches are slowly getting smaller and smaller. I probably should drill this. You know what, that's okay. I'll be all right. I should drill all these out, because if I have to hold it in a vise, I could scratch it up again, and I would then be right now wasting my time. But I do want you to see this. Not the whole thing, but I really just want you to get an idea about, and then they're almost gone. Let's see if I can get that just right.
just right. I'm just moving around in the light, so maybe one of these angles you'll see just there's barely any. They're right in here. They're right in this area here. Okay, so we're real close on this one. So I'm just gonna. The water is keeping the sandpaper from moving around. It creates like this vacuum. There'll be people out there, oh, you should do it this way and you should do it that way. Yeah, you know what, I know, but this is how I'm doing it right now. You don't need to have a micro flat to do this. You just need to have a flat surface. A piece of glass works very well. So if you have an old piece of glass or something, that works really well. So there's very, very little, very few. They're mostly scratches from the sandpaper, and then the next grit will take care of it. Okay. What I'm going to do is I'm going to do the other side, and I'm going to do the 400, and so and then I'll see you in a minute. Okay, so we're looking pretty good here. Here's our part. I sanded at 320, and I stopped. I wanted to make sure that everything worked. Here's our screw, this little tiny number 2 brass screw, and it drops right in there. See that? Right. And then there it hangs out the bottom, and it does it on both sides, I think. Yeah. Okay. And then let's check the fit of the rollers and the everything else. All right, so that one needs to be deburred. And that one needs to be deburred. That one is good. That one's good. This one needs to be deburred. And this one needs to be deburred. So that, deburred there, deburred there, deburred there, deburred there. Okay, so I got what's this tapered hand reamer. And I'm just using this as just to cut that edge and see what happens. Like there's just this little tiny burr there. And there we go. I'll get these on. One more. Okay. Now, of course, I'll tell you what we're making soon, all right? But I'm still going to keep it a surprise. This gets screwed on to what we're making first. Let's see if these even fit in here. Oof. All right, so looks like there's some burrs. These are, they do go in. All right. Yeah, I think that there's just some burrs in there. So what we'll do, I'm gonna have to get the sandpaper out. Let's see what happens though. I'm not gonna force it. All right. It's a little tricky. I have to put this in the vise, line everything up. Oh, there it goes. So yeah, that's there. That's definitely going to go. And it went. There's our, yeah, and there's even spinning, yeah. So there's our assembly. That looks pretty good. I need to, there's our assembly. That looks pretty good. I'm pleased. They spin. I do need to deburr the grooves just a little bit more. All right. So anyway, cool. Right on.